Okay, last one of the day for me. I don't know where you're at, but it's been a long day. So let's get through this. I'm going to talk about the Doppler shift, and I've got some assumptions here. We're going to actually do a problem now instead of just doing demonstrations. And again, demonstrations with sound are much better in class than over the web. I've tried my best, but let's just get to it. So some assumptions. We're going to assume that the source and the observer move collinearly, meaning along the same axis. That doesn't mean they're moving the same way. They could be moving towards each other, away, or they could be both going, or both. Yeah. So, but they are moving along the same, let's just say, x-axis. All right. If you want to learn more if they're moving perpendicular to each other, you could read about the transverse Doppler shift, but I don't recommend that right now. Let's just learn the basics of things going directly at or away from each other. All right? We're going to assume that the speed of the observer is much, much less than the speed of sound if we want to use this formula. We're going to assume that the speed of the source is much, much less than the speed of sound. Okay, we can talk about supersonic motion and Mach numbers in a later video. But in this case, you'll see this written in a couple of different ways. Sometimes I'll just write f prime, and by that I mean the frequency observed by some observer. So if you have a source here that's moving, and maybe you have an observer here that's moving, f prime would be the frequency that this person hears, that they observe, right? And so, now, the source frequency is f naught, or f subscript 0, and then notice this unusual plus minus and minus plus. This is a little bit sneaky. So, it probably seems reasonable that if you're moving towards, if you're coming together, you should think, the frequency should go up. The waves are going to hit me more frequently. I should have a higher frequency observed. So let's see how these plus minus signs make sense. We want a plus for the V observer if it's moving towards. Well, let's think. If I have a plus sign here, that's going to make f prime bigger. Now in the basement, if they're moving together, I need to use a minus sign. Right? Because then I have a smaller denominator if they're coming together, so I get a larger frequency. So that's the origin of this plus minus minus plus. Or you can just kind of think it through like that if you're confused which way to do it. Just be like, if they're moving towards each other, the numerator has to get bigger and the denominator has to get smaller. That's why we use a plus here and a minus there. And obviously you could have them both going the same directions. If they were going the same direction, think about it. We should get no shift. If you're going the same direction, we'd use a plus up top, and then if they're going, we would have to use a plus on bottom because the source would be moving away. We'd have to use, so if I had, this works in that case too. If they're both going the same direction, we get no shift because I'd use a plus here and a plus there. One's going away from the other one. All right, let's just get to the numbers. Let's get to a problem with numbers. Let's do it over here. So let's say we have Zoltan, a guy I washed dishes with in college. He's emitting a frequency. Maybe he's just got a nice clear, uh-oh, I'm in trouble. Okay, uh-oh. Just a second. Hey, I'm mid-video, I'm about to leave. Okay, I'll talk to you soon. Bye. Well, that's exciting. That's in the vid now. All right, so sorry about that. Zoltan screaming at 1 kilohertz. Oh my gosh. Calm Cruise is on top of the train. My phone's ringing. The world's about to explode. What are we gonna do here? This train's coming at 20 meters per second straight towards Zoltan's face. He's done washing dishes. Okay, so let's try to do this problem. What frequency is observed by Calm Cruise on top of the train, some daredevil, and what frequency is observed by Zoltan when the echo returns? This is one that gets a lot of people. So let's do part A first. We know that f prime is equal to f naught, and then going back to our formula, let me just get that formula on screen here. Okay, it was V sound. Let's assume V sound, unless otherwise specified, is 343 meters per second. So we've got V sound, and then what's on top? What do we got here? V sound plus V observer. Well, the observer is coming towards him. I should use the plus sign. So plus, I'll call it V train, because ComTrues is on the train. Then on the bottom, what is the speed of the source? 0. All right, so F prime, if you want to race me, go ahead and punch in the numbers. What will ComTrues here? So what was the frequency? 1 kilohertz times, okay, so 343 plus 20 divide by 343. Okay, and so it should be 1.058 kilohertz. So we'll hear a 60 hertz increase in the frequency. If you're curious, you could go and read about beat frequencies, and this is how radar guns work, right? Well, more on that in a minute. So part B is the interesting one. F double prime is the frequency that Zoltan will hear. Now, here's what's weird, right? The echo is now being reflected by this source. So the train becomes the source and it's moving. And the frequency that gets shifted is F prime. So that's going to be F prime times V, what was it? Sound plus V observer, which is 0. Zoltan's the observer of the echo. Over V sound. Now, do we want to use minus or plus? The source is coming towards Zoltan, right? The source of the echo is the train. So we want to use minus so that we get a small denominator, which amps up the frequency even more. So minus V of the train in this case. So now when I do this, let's go ahead and punch this in. Let's see. That answer times 343 divided by 363, which is, wait, no, I almost screwed up. 323? Let's see. 343 minus 20, because they're coming together. Okay. I got 1.124 kilohertz. So this is the tricky part. When you have an echo, you got to remember to shift the shift. All right. So hopefully that helps you understand that. There's not much more to that. And